Hey, I'm Stephan Papadakis. You're here at our race shop in Carson, California, and we're continuing our project trying to make 1,000 horsepower out of this 2020 Supra engine. We've already done a teardown and a video describing all the different changes that we're making to the engine. I'll link to both of those videos in the description down below. But for now, we're going to do the assembly. Let's get started.
The first thing we're going to do is put the crankshaft in. I'll flip the engine over and we'll start putting all the main bearings in. The block actually was never even washed. I disassembled it, wiped it down. Everything was so perfect and so new. We're actually putting it back together with the same bearings and just wiped down. Now we'll put assembly lube. This is like a special thick assembly lube that's really tacky and stays put. We'll go ahead and grab the stock crankshaft. It would be nice to stroke it to a bigger displacement, but for now we're going to stick with the stock one. We're pretty confident it's going to hold up to the horsepower we want to make. Next, we're going to put the main caps on, and the bearings are already assembled on the main caps. They're all numbered 1 through 7, and this is an interesting feature for these main caps. Instead of having a dowel or something that aligns them, they have these grooved features that actually dig into the aluminum in the block and mark it. If you look, you can see a couple of lines where they line up. The number 3 main cap has the thrust bearings. Next, we'll put in the main bolts. The main bolts actually use what they call an e-Torx socket. There's actually a lot of e-Torx and just Torx bolts on this engine. It took a little bit of getting used to, but actually once I worked with it for a while, I didn't see that there's necessarily a downside from traditional hex bolts. So I'll cinch them down a little bit by hand to make sure everything feels okay, and then I'll go and torque it. I got these trick torque wrenches that not only do the normal torque, but also measure the angle. The way you torque these is an 18-degree base torque, and then 65 degrees additional, plus another 65 degrees. And these torque wrenches are really tricked to where you can switch in between. So I can go 18, and then hit a button, and then it goes to 65 degrees. Turn the bolt 65 degrees, it knows how far you've gone, and then you just keep going down the line. It even counts how many bolts you've torqued. And again, I'll just make sure that everything spins properly. Now we're going to install the custom forged JE pistons and also the chromoly Corolla rods. And you'll also notice that the pistons are coated. There's a special coating on the top that helps resist the heat, and then the black coating on the side is to help with wear on the bores. What I'll do is get everything out of the way, and you put these little clips in first. These little clips are what holds the pin from sliding out, and these are always a bit of a pain. I haven't really found a really elegant way of doing it. I do have a special tool, but that special tool I don't have for this diameter pin. So we'll go back to the old school style of using a screwdriver and manually assembling it. Once the pin's installed, and then double check and make sure the piston and rod are orientated the right way. Because the valve reliefs on the top of the piston are slightly different position and size, you want to make sure that you orientate that right with the rod. So I'll double check and make sure those clips are installed all the way. These are actually the rings that came out of the engine. We designed the pistons to work with the factory Supra rings, and we're actually not even doing anything to the bores. So we're sticking with the same bore, the same hone, the same rings, and we're just replacing the rods and pistons. So there's a spring that goes on first before the oil scrapers, and then the oil scrapers go on all to that bottom ringland. The middle ring is usually a cast ring, and that's why you don't want to like twist it so much. So what I'll do is I'll just open it up from the center, and then the top ring you can actually twist on with no problem. We'll go ahead and install the rod bearings, and the top rod bearing is actually a coated bearing. The bottom uses a more traditional bearing. We actually had the rods made, so in the future, if we want to put the top coated bearing also on the bottom, the tang will align up, so we can actually use either type of bearing on the bottom. But for now, we're just going to stick with the stock setup, see how that wears, and then go from there. I'm going to continue to get everything all prepped, including the assembly lube on the bolts. That way, when we go to install it, it can just go through the line and install all 6 of the rods and pistons, and not have to worry about getting dirty or anything like that with the assembly lube. Now you see one of the reasons I wear the gloves, quick cleanup. So I'll put some fresh gloves on, get assembly lube on the bearings, and then just engine oil on the piston skirts and the rings. To install the pistons, we're going to use this tapered piston installation tool, and ARP makes them in a bunch of different sizes. So this is an 82 millimeter bore. I just ordered it up to 82 millimeter, and it's tapered inside, so it's able to fit in the top with the rings and everything, and then it slowly compresses all of the rings down until it's exactly 82 millimeters, which is with the bore, and then pop, it slides right into the bore. We'll flip it over, and then I realized, wait a minute, I can't turn the crank. I need to put the pulley on first. As you can see, it's a different type of pulley, where instead of having a snout on the crankshaft and then the pulley slides over it, this is a flange style one where it just centers, and then you've got the 4 bolts. In order to torque it, I asked Sean to help me out. We got a couple of bolts in the back where the flywheel goes, and then I was able to torque it. Now you can see there's a couple of dowel pins that align the rod bearing cap. Once we've got those aligned, put the pre-lubed bolts in. I'll zap them in real quick to a low torque, and then torque them to their spec. I'll go ahead and do all of the 6 rods and pistons just like that. Once I get them all in, make sure everything turns well, there's clearance everywhere, everything looks great, so we'll move on to the head. So this is a big lower baffle brace that ties in all of the main caps with the skirts of the block and helps the whole rigidity of the block. I'll torque that on. Next, we're going to install the oil pump. So there's a special chain that connects the crankshaft with the oil pump. So I'll install that first and then bolt on the oil pump. And once we get that all bolted on, I can go ahead and put the oil pump gear on. Once the oil pump's all installed, I'll again make sure everything turns normal. The rear timing cover, I'll put some silicone on it. But before we install it, I got to put the main timing chain on it and both of the guides. So stock, this engine takes torque to yield head bolts, but they're not reusable, and we wanted to torque it a bit higher because of the boost pressures and horsepower we want to make. So talked to ARP, and ARP actually made us a custom set of studs for this engine, and it's really trick because the washers have a knurled side, and the knurled side goes down towards the aluminum, and the smooth side is up towards the nut. That way, when you torque it, only the nut is turning on the washer, and the washer doesn't turn on the aluminum side, and that actually gives you a bit more consistent of a torque. This is actually a factory head gasket that's multi-layer steel, and they put the orange sealant on there to help seal up all of the oil and coolant passages. I like to put assembly lube on all of the studs before I put the head on, because once the head's on there, it's hard to get to all of those threads because they're kind of deep into the head. The head we're putting on has had a bunch of work done to it. It's got SuperTech valves, springs, retainers, keepers, and this should handle the power that we want to make. We've also ported it and done a bunch of work to the flow, and if you're interested in that, check out the previous video to this, and we talk about all of it, and I show you everything on the flow bench. Once the head's installed, I'll go ahead and put the washers, I'll put assembly lube on the top of the washer, and then get that nut on there and torque it all down. In order to torque these, though, because it's such a high torque, 135 foot-pounds, I'm going to go get the big half-inch drive bad boy, and we'll torque it with that. But even with the big torque wrench, it's actually still a lot of work, because if you think about it, if this thing's 2 feet long and I'm doing 135 foot-pounds, then, you know, I'm pulling almost 70 pounds each time I get to maximum torque. But that's what you need to do when you want to try to keep the head down with all of that boost, because when you're making big boosts, when you're making big power, there's really high cylinder pressures, not only push down on the piston, but trying to push up on the head as well. There's a really elaborate valve train in this, and this is like a third camshaft. And that camshaft we'll get to in a minute and how that works. But first, we're going to put all the rocker arms in. The rockers have a little hydraulic lifter, which they pivot on, and then the other side is on the valve. The cam sits on top of it. Like most modern engines, this one uses roller rockers, so when the cam pushes down on the rocker, it actually pushes down on that roller, and the friction is much lower than the old style where the cam pushes on a pad and actually slides on it. So we'll start with the exhaust cam, but when I noticed, I was like, oh, wait a minute. When I put the cam in, I got to line everything up, because remember, this is the first time I've actually assembled the engine. The first time I've disassembled one of these engines was in the other video during the teardown, and now this is the first time I'm assembling one of these engines, and I realized, wait a minute, I have to line everything up, but there are no timing marks on the pulley. After a little bit of research, the way you actually line up for top dead center is you need the flex plate on there. So I went and installed the flex plate. It only installs one way, and you need the oil pan to actually line it up. So in order to turn the engine over, I had to pull the rocker arms back off, because when I turned the engine over, I didn't want the rocker arms to fall back out. So I installed the pan, and then next we're going to install the oil level sensor. There's actually no dipstick in this engine to check the oil level. It's all electronic with that sensor. So once I got that installed, I can install the special tool, and the special tool goes through the oil pan through a hole and lines up in the slot, and that's top dead center. That's when the piston of number one cylinder is all the way at the top. I need a little break. So had a little candy bar, and did I lick my fingers? Anyways, so back to the engine, got the rockers back in there, and now we're installing the camshafts. Well, so the camshafts are all phased a little bit different depending on the firing order of the cylinders. When you install the exhaust cam, the lobe is actually pushing down and it doesn't sit flat. So they actually make a special tool for that. And once you bolt it to the head, it's got these fingers that push down on the rocker arms and compress the springs and open up the valve for that cylinder, and allows the cam to come down and sit into the bearing races. In order to get all the cam chain lined up properly, you need these special tools. And the way it works is this bridge bolts to the cylinder head, and then there's these two like teeth part that then go and index themselves on the flats of the camshaft. Once I got all that lined up, I could put the timing chain on and then install and torque all of the cam caps. Next, you'll see this little motor. And what this does is it adjusts the third camshaft, which changes the rocker ratio for this intermediate rocker. And it's a really trick setup. And what happens is it's a variable valve lift intake cam that changes the valve lift depending on where that cam location is. For this build, we're going to end up locking all of that system out to maximum lift, but I haven't designed those parts yet. But for now, I'm going to assemble the whole thing like stock and then make some parts a little bit later. The intermediate rockers are guided by these gate parts, and they each have this slot in it that keeps the intermediate rocker all lined up properly. And when I took this engine apart, I didn't have the special tool for the intermediate rocker springs. And I got it apart. It wasn't very elegant, but I knew I needed it when I reassembled it. And I'll tell you what, at first I was like, dude, this sucks. All these springs and all these special tools. But once I got the tool and then used it, it was like not even a problem. You just put the spring in the tool and it has these little teeth that hold the two spring parts. You then compress it, set it up in the cylinder head, and then the spring ends go onto the intermediate rockers. And then once you release the special tool, it's installed. I've never even used the tool before, and I installed all of this in like less than 10 minutes. If you have the special tool, it's totally fine. Once all the valve train is installed, then I can install the hydraulic timing chain tensioner and torque that in as well and make sure it spins nicely, followed by putting in the spark plugs. Again, torquing the spark plugs as well. So the valve cover started off black and it's plastic, but I wanted to do something trick, and we actually found this thing called Cerakote, C-E-R-A. It's like powder coating, but they can do it on the plastic. So it's pretty amazing, and they had a red I really liked too. Once the valve cover is all installed, I can install the direct injection injectors. So this is the fuel injectors that go directly into the combustion chamber. We're probably not going to use these for our application, but in order to fill those holes that go into the combustion chamber, we're just going to leave those installed for now. Once I've got the spark plug coils all installed, we'll wheel the engine out to the other room and we'll get all of the intake and exhaust stuff on. The stock intake manifold has an intercooler built inside of it, but we don't want to use it there. We want to use a traditional front mount intercooler, and we're also going to use port injectors. So we designed a special aluminum intake. And because we needed it so quick, we had it 3D printed out of aluminum. Believe it or not, they can print stuff out of aluminum nowadays. Thanks to the guys at Mimotechnik for printing the intake manifold. They knocked it out of the park. This thing's amazing. So I actually have a bunch of footage from this that I'm going to put in a YouTube video soon. But for now, just show you a couple of pictures with the plenum and the runners. The whole thing wouldn't fit into the printer, so we had to print it into sections and then weld it together. We'll install the stock throttle body that we're going to continue to use and then move over to the exhaust side. Once we have the studs installed, I can install both of the exhaust gaskets and then the turbo header we got from Full Race. The Full Race made us this exhaust manifold, and I was like, could you guys please make the bolts easy to get to? And they actually really were. So thanks to those guys for making this thing easy to work on. Then we'll put the turbine housing on, and then the whole turbocharger slides right in, and a couple of bolts that hold the turbocharger together. On this setup, we're going to run dual external wastegates. So the way the wastegates work, the exhaust gases go through the header tubes and then turn the turbine wheel, which turns the turbocharger. But when it gets to enough boost, you want to actually divert some of that exhaust gas and just go out into the atmosphere. And the way that works is there's a valve inside the wastegate, and when we hit a certain amount of boost, the valve will open and divert gases. Instead of going through the turbocharger, it'll go through the wastegate and then not turn the turbocharger any faster. And that's it. We're all assembled. I really like how it turned out. Not only the way the engine assembled, but also the looks of the engine as well. The red valve cover, I think, really just tops it off. It's like the cherry on top.
All right, thanks for watching. I hope you enjoyed it. If you did, please hit the like button. If you want to see more, please consider subscribing. The next video, we're going to go and take this thing to the engine dyno and try to make the 1,000 horsepower. For now, we'll see you later.